Hello everyone, welcome to the next session. In the previous session, we have seen the numericals on horizontal venturimeter. In this session, we will see some numericals on inclined venturimeter. Let's start with the first one. A 30 centimeter by 15 centimeter venturimeter is inserted in a vertical pipe carrying water flowing in the upward direction. When you read this term upward direction, it simply means that it is a case of inclined venturimeter. So the data given is a vertical venturimeter. Inlet diameter D1 is 30 centimeter, which I have converted into meter and calculated the area A1. When I say 30 centimeter by 15 centimeter, it obviously means the first diameter is inlet and the second diameter is a throat diameter. The throat diameter, as per the figure that you have seen, will always be less than the initial diameter. So D2 is given to me as 15 centimeter, which is converted into meter, and I have calculated area A2, which is the cross section area, so pi by 4 d2 square. The differential mercury manometer connected to the inlet and throat gives a reading of 20 centimeter, which means the manometer reading X is given as 20 centimeter of mercury. I converted it into 0.2 meter of mercury. Find the discharge, which means I have to find the value of Q, and the CD value is given to me as 0.98. You know the formula of Q now. It is CD A1 A2 root of 2GH upon root of A1 square minus A2 square. The formula in case of horizontal venturimeter and inclined venturimeter for discharge remains the same. The formula of H is also same, X into SH upon SF minus 1. I have the value of X, I have the value of SH, which is 13.6, and the flowing fluid being water, so the value of SF will be 1. When I substitute, I get the value of H as 2.52 meter of water. When I substitute all the other values in the formula of Q, I'll get the answer as 0.1257 meter cube per second. I can convert it into liters per second as well. Let's go to numerical 2. A 20 centimeter by 10 centimeter venturimeter is inserted in a vertical pipe carrying oil of specific gravity 0.8. The flow of oil is in upward direction. Again, the term upward direction indicates that it is a case of vertical venturimeter. The inlet diameter D1 is given and the throat diameter D2 is given as 10 centimeter. I have calculated the area for both of them using the formula pi by 4 d square. The difference of levels between the throat and inlet section is 50 centimeter. The difference of level between throat and section is given. Now water is flowing from 1 to 2. Hence the level 2 will be higher. So Z2 minus Z1 is 50 centimeter, which is 0.5 meter. The oil mercury differential manometer gives a reading of 30 centimeter. So the manometer reading X is given as 30 centimeter of mercury, which is 0.3 meter of Hg. Find the discharge of oil, neglect losses. The specific gravity is given as 0.8. We have to find the discharge Q. Q is given by this formula. CD is 1. I have assumed it 1 because it is said in the problem to neglect the losses. Now there are two formulas for H, P1 upon rho g plus Z1 minus P2 upon rho g plus Z2, and the other is X into SH upon SO minus 1. Now if you look at the problem, Z2 minus Z1 is given to you, but P2 upon rho g and P1 upon rho g has no data given. So I cannot use this formula. I have to use this formula for which I know all the values, and I get the answer as 4.8 meter of oil. This is very important because the question is saying that the flowing fluid is oil, and if I substitute this value of H in this formula, I'll get Q is equal to 0.07872 meter cube per second, or it is 78.72 liters per second. Thank you.